Welcome to today's Explainer, everyone. So today we're breaking down a biological mystery that's, well, it's as fascinating as it is frankly tragic for our little flying friends. We're going to look really closely at a phenomenon most of us actually know about, but, rarely truly understand from a structural standpoint. Let's just jump right into it.
Have you ever thought, my friend, why exactly a honeybee dies after it stings a human being? I mean, sure, it's a super painful encounter for us, but the bee literally pays the ultimate price. But why? Like, what is actually happening down at a microscopic level that turns a really simple defensive strike into this fatal event? To understand this, we actually have to look at the mechanics of the sting itself.
Okay, let's dive into this. And to really grasp what's going on, we first have to establish a biological baseline. You see, when a honeybee attacks another small insect, say like an ant, it just strikes, does its job comfortably, and flies right away. It's a totally harmless encounter for the bee. Absolutely no tragic ending here. So what exactly changes when it encounters us?
Well, the difference all comes down to the battlefield, specifically the layers of the skin. Tiny insects have these incredibly thin, super smooth outer layers. A bee's stinger can just puncture that layer and slide right back out with zero resistance whatsoever. But human skin, it's remarkably thick. It's dense, it's layered. When the bee inserts its stinger into us, that thick human skin suddenly creates an inescapable biological trap.
Now, what's really interesting about this is the microscopic culprit behind the trap, the bee's weapon itself. This isn't just some smooth, straight needle like a doctor's syringe. No, it's what biologists call a barbed stinger. If you look at those sharp, backward-facing hooks lining the edges, it functions almost exactly like a microscopic fishhook. And those very same hooks are exactly what seal the bee's fate when it comes into contact with our thick biology. So let's just walk through the sequence of really inescapable tension. Step 1. The stinger pierces our thick skin. Because of those backward-facing barbs we just talked about, it goes in super easily, but it absolutely cannot come back out. The dense layers of our skin literally close right around those jagged hooks, locking it firmly in place. Step 2. The bee realizes it's stuck. Survival instinct completely takes over and it begins to strain. It pulls backward with its maximum possible force, just desperately trying to free itself, which, tragically, rapidly leads us to step 3. When the bee pulls with all of its might against those locked barbs, the stinger doesn't budge, not even a little. Instead, the weakest point of the connection is what gives way. As our source material puts it, then the bee's body tears in 2 pieces, as a result of which the bee dies. It's such a tragic physical outcome. The bee's lower abdomen physically tears apart simply because that stinger is anchored so incredibly securely in our skin. Which kind of leaves us with a profound question, right? Is this ultimate sacrifice just some bizarre evolutionary flaw, like a glitch in nature's design? Or is it actually the perfect defense mechanism for the greater good of the hive? I mean, it ensures that a lingering venom-pumping deterrent is left firmly embedded in any large predator. I really want you to ponder that today. Nature rarely makes mistakes, Sometimes the ultimate sacrifice really does serve the ultimate purpose. Thanks so much for joining me for this explainer. Keep questioning the incredible mechanics of the world around you.